Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video we are gonna learn how to calculate probability of dependent events. I have already taught you how to calculate probability of independent events and I'm not gonna talk about that anymore. Instead, I'm gonna put the link of that video in the description. Okay, without wasting any more time, let's jump into today's lesson. The first thing that we need to learn in this chapter is the definition of dependent events. What does it mean when we use this term? Events are dependent if the outcome of one event affects the outcome of other events. What does it mean? It means events are related to each other. The result of first one is going to have impact on other trials, on other experiments. So we cannot investigate them separately. They are related to each other. What is the example of that? Assume that we have a bag and this bag contains 5 red balls and 5 blue balls. We are gonna pick two balls without replacement. Assume that in the first trial, I'm gonna pick 1 red ball. In that case, for the second trial, the sample space is gonna change. The possibility of getting red ball is gonna change. The possibility of getting blue ball is gonna change. And everything is gonna change. So events are related to each other and they are dependent events. And we have really important word here. Without replacement, in 99.9% of questions that you can find this word, without replacement means you have dependent events. Okay, we got familiar with the definition of dependent events. What should we do for solving probability of dependent events? I'm sorry, this is wrong. Dependent events. We are going to use this formula. P, which is probability of A, then B is going to be equal to P of A times P of B after A. What does it mean? How are we supposed to use this formula? Is it really complicated? Would it be difficult to use this formula? Don't worry, I'm going to explain that through examples. We are going to learn that completely with examples as always. Look at the first example. We have a bag that contains 2 cards, which is written A on them, 3 cards of B, 4 cards of C. In total, I have 9 cards. You randomly pick 1 card without replacing. What does it mean without replacing? It means we have dependent events, okay? If it was written with replacing, in that case, it was independent events. And then pick a second card from the remaining card. What is the probability that first card is A, so P of A, and the second card is a C, so P of A, then C. We are looking for this probability is gonna be P of A, based on the formula that I taught you, times P of C after A. Okay, let's calculate each one of them separately. The first probability that I'm gonna look for it is the probability of getting A. Number of favorable outcomes divided by number of total outcomes. How many A's do we have? How many favorable outcomes do I have? 1, 2, and it is written here. So 2, and how many cards do I have? 9. So it's gonna be 2 over 9. And the important part is gonna be P of C after A. In this case, what should I do? Assume that I already picked 1A. So I'm gonna eliminate that from the sample space. In that case, what would the probability of getting C? I need a C, right? So what is the number of favorable outcomes? As you can see, 1, 2, 3, 4. So it's gonna be 4 over what is the number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. Why is it 9? It is not 9? Because I have already picked 1 card and it was A. And it's gonna be 1 over 2. Really easy. Now I'm gonna find the probability for this question. It's gonna be 2 over 9 times 1 over 2. It's gonna be 1 over 9. Really easy. Assume that you have some cards and some letters are written on those cards without replacing again the card that you pick one card, then you choose a second card. Find each probability. The first probability that we are looking for is vowel, then K. So it's gonna be equal to P of vowel multiplied by P of K after vowel. This is the last time that I'm writing the formula because I believe that this is really easy and understandable. So let's find the P of vowel first. How many vowel letters can you find in these cards? E is one of them, O is one of them, and that's it. So number of favorable outcomes is gonna be 2, and number of total outcomes are gonna be 1, 2, 3, 4, 5, 6, 7, 8. So 2 over 8 or 1 over 4. Okay, the difficult part, which is not difficult. PK after vowel. I'm gonna show that with V. Assume that I already picked one vowel. It can be E or O. I'm gonna eliminate E. In this case, I'm gonna find the probability of K. What is the number of possible outcomes? As you can see, I have one possible outcome in this case. One favorable outcome, I'm sorry. What is the number of possible outcomes? It's gonna be 1, 2, 3, 4, 5, 6, 7. Why it is not 8? Because I have already eliminated E from the sample space. So it's gonna be 1 over 7. And I can easily find this probability by multiplying these values by each other. It's gonna be 1 over 28. Really easy. Here again we have those cards, and in this case we want to find the probability of N, then S. I told you I'm not gonna write the formula again, but here I'm gonna write it one more time. P of N multiplied by P of S after N. Okay, we are gonna pick N first. What is the number of favorable outcomes? 1. And what is the number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. So 1 over 8. And P of S, probability of S after N. In this case, we need to eliminate N because we have already picked that. And what is the number of favorable outcomes? As you can see, I have one favorable outcome. And in this case, I have 7 possible outcomes. Why? Because I have already eliminated one of the cards. So this probability is gonna be 1 over 8 times 1 over 7. It's gonna be 1 over 56. Really easy. This one can be a little bit tricky. Let me write the cards. Assume that I have N, E, T, W, O, R, K, S. These are the sample space. We want to have vowel, then O. Why I told you that this is somehow tricky? We are gonna learn that. So P of vowel times P of O after vowel. Let's talk about the first one. For the first one, I can have 2 favorable outcomes. My favorable outcomes are gonna be E and O. But wait here, I have a question. O is a favorable outcome for the first probability. what would happen if I pick O? If I pick O, the second probability, which is picking O, would be impossible because I'm not gonna replace the card. So for the first one, I'm gonna have only one favorable outcome. I cannot consider O. Why? Because I need O for the second probability. Did you get that? I cannot yes, O is vowel. And if it was normal question, I would consider two favorable outcomes for the vowel. But because I need O for the second probability, I'm not gonna consider that as a favorable outcome for the vowel. So P of vowel is gonna be 1, which is only E over 8. And for the second one, I'm gonna eliminate E. For the second one, O would be favorable outcome. So in this case, I'm gonna have one favorable outcome over 7 because I have already eliminated the E letter. So the probability is gonna be 1 over 8 times 1 over 7, and it's gonna be 1 over 56. Really easy. We have 4 girls, 3 boys from a class volunteer to be representative. Their 7 names are placed in a bag. Their teacher randomly select one name and then without replacing it. This term shows that we have dependent events. Select the second name from the bag. What is the probability that both selected representatives are girls? So I want to find the probability of girl, then girl. So it's gonna be P of G times P of G after G. I do not know if it is needed to write the sample space or not, but I'm gonna write it for you anyway. I have 4 girls. 1, 2, 3, 4. 3 boys. B, B, B. Then I'm gonna find the probability of picking a girl's name. What is the probability of that number of favorable outcomes? 1, 2, 3, 4. 4 number of possible outcomes. It's gonna be 7. And for P, girl after girl, what should I do? In the first probability, I have picked a girl's name, so I'm gonna eliminate that from the sample space. In this case, what is the number of favorable outcomes? As you can see, I have 3 favorable outcomes. So it's gonna be 3. And number of possible outcomes, it is 6, which is gonna be 1 over 2. So I found those 2 probabilities, and the only thing that I need to do is multiply them by each other. And it's gonna be 2 over 7. Really easy. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.